Have you ever wondered what a bipolar junction transistor is and how it works? Well, you're in the right place. Today we're diving into the intriguing world of electronics, specifically focusing on a fundamental component known as the bipolar junction transistor, or BJT. This tiny device plays a critical role in controlling electrical signals, and you'll find it in everything from your computer to your car. In this video, we'll explore what a BJT is, its structure, and how it operates. We'll also discuss why this little powerhouse is so crucial in the world of electronics. Whether you're a seasoned engineer, looking for a refresher, or just someone curious about the inner workings of the gadgets around you, this exploration will shed light on the magic that happens within these tiny electronic components. So, are you ready to turn up the voltage on your knowledge? Stick around as we delve into the fascinating world of bipolar junction transistors. Transistors, tiny as they may be, play a colossal role in the realm of electronics. Let's dive into the world of transistors and their importance. You see, a transistor is a crucial component in virtually all electronic devices. It's a miniature electronic switch that can amplify electrical signals or open and close circuits, influencing other parts of the system. Think of it this way: it's like a gatekeeper, controlling the flow of electricity, much like a tap controls the flow of water. It can either allow current to pass, block it, or amplify it, enabling us to manipulate electrical signals in a variety of ways. This function is what makes transistors the building blocks of modern electronic systems, from your smartphone to your microwave oven. Now, there are several types of transistors, each with its unique characteristics and uses. Two of the major types are the field effect transistors, or FETs, and the bipolar junction transistors, or BJTs. FETs are voltage-controlled devices, meaning they regulate current flow based on the voltage applied to them. On the other hand, BJTs are current-controlled devices, meaning the current flowing through them determines the output. But today we'll be focusing on bipolar junction transistors, or BJTs. These transistors are a bit like the unsung heroes of the electronics world. They're used in a vast array of applications, from signal amplification and regulation to switching, and even in some types of computer memory. They're incredibly versatile, and understanding how they work is a fundamental part of electronics. In their simplicity, transistors have revolutionized our world. They're at the heart of the technology we rely on daily, from the simplest gadgets to the most complex systems. Without them, we wouldn't have computers, smartphones, or even the internet. So that's the basics of a transistor. Now let's focus on bipolar junction transistors. Bipolar junction transistors, or BJTs, come in two types, NPN and PNP. Each of these acronyms represents the order of semiconductor layers within the transistor. So what exactly are these layers? Let's dive in. At its core, a BJT has three layers of semiconductor material, each with a unique role. Picture a sandwich with three distinct layers: the emitter, the base, and the collector. The emitter layer is where the charge carriers, either electrons or holes, are emitted or injected into the base. The base, being the thinnest layer, is where these carriers transit. The collector, true to its name, collects these charge carriers. Now let's talk about the difference between NPN and PNP transistors. In an NPN transistor, the sandwich layers from top to bottom are N-type, P-type, and N-type semiconductors. This means that the emitter and collector are both N-type semiconductors, which carry an excess of electrons, while the base is a P-type semiconductor, which has a deficiency of electrons or an excess of holes. In contrast, a PNP transistor has a P-type semiconductor for the emitter and collector and an N-type semiconductor for the base. This means that the emitter and collector have an excess of holes, while the base has an excess of electrons. The choice between NPN and PNP transistors depends on the direction of current flow you need in your circuit. In NPN transistors, the current flows from the collector to the emitter. In contrast, the current in PNP transistors flows from the emitter to the collector. So, in essence, the structure of a bipolar junction transistor is all about the arrangement of N-type and P-type semiconductors into an emitter, base, and collector. This structure, along with the type of transistor, determines the direction of current flow. Now that you understand the structure, it's time to learn how it works. Ever wonder how a tiny BJT can control and amplify currents? Well, let's dive in and see how these remarkable little devices work. Picture a bipolar junction transistor, or BJT, as a sandwich with three layers: the emitter, the base, and the collector. These layers are made from semiconductor material, either silicon or germanium, doped with impurities to create two types of charge carriers, electrons and holes. The magic of a BJT lies in its middle layer, the base. This layer is incredibly thin and lightly doped, meaning it has fewer charge carriers. The base's thinness allows the majority of electrons or holes from the emitter to pass right through to the collector. Now, here's where it gets really interesting. The flow of current through a BJT is controlled by the voltage applied to the base. A small change in the base current leads to a large change in the collector current, essentially amplifying the input signal. Think of the base as a gatekeeper or a traffic cop, controlling the flow of electrons or holes. When the base emitter junction is forward biased, meaning the base is positive with respect to the emitter, the gate opens. Electrons or holes flow from the emitter through the base and into the collector. On the flip side, if the base emitter junction is reverse biased, the gate closes. The flow of charge carriers stops, and so does the current. It's this ability to control a large current with a small one that makes BJTs so important in electronic circuits. They serve as the building blocks for amplifiers, oscillators, and switch circuits, playing a crucial role in devices from radios to computers. So the next time you're listening to your favorite song or browsing the web on your laptop, remember the humble BJT. It's working hard, amplifying signals and controlling currents, all on a microscopic scale. That's how a bipolar junction transistor works. But why does it matter? Stick around and we'll explore the significance of these tiny powerhouses in the next scene. BJTs are more than just tiny electronic components. They have revolutionized the world of electronics. These small but mighty devices are the foundation of modern electronic and digital systems. Let's delve into their importance in our day-to-day lives. Transistors, particularly bipolar junction transistors, are the backbone of the electronics industry. They are the key players in the amplification and switching of signals. They make it possible for your favorite song to blast through your speakers, for your TV to switch channels, and for your computer to process complex data. BJTs act like a gate, controlling the flow of electrical current. This ability to control current makes them invaluable in signal amplification. Imagine trying to listen to a radio station with a weak signal. Without the amplifying power of BJTs, that signal would remain weak and the radio station would be almost inaudible. But with BJTs, the signal is amplified, allowing you to enjoy your favorite radio program. But that's not all. BJTs are also used extensively in electronic devices. They can be found in the integrated circuits of computers, in audio amplifiers, and even in your car's ignition system. In fact, they are in almost every electronic device you can think of. Consider your smartphone. It's much more than just a tool for communication. It's a mini computer, a camera, a music player, a GPS, and much more. And guess what? It's all made possible by the humble bipolar junction transistor. BJTs have truly transformed our world. They've made it possible for us to communicate across vast distances, to access vast amounts of information at the touch of a button, and to enjoy high-quality audio and video entertainment. They've made our lives easier, more convenient, and more connected. BJTs have truly transformed our world, making it possible for us to enjoy our favorite electronic devices. So, to wrap things up, let's summarize what we've learned about bipolar junction transistors. We dove into the world of transistors, exploring their intricate structure, which comprises of three layers of semiconductor materials: the emitter, base, and collector. We discovered that these components work in harmony, controlling the flow of electric current and amplifying signals. We then delved into the magic of how bipolar junction transistors, or BJTs, function. It's a fascinating process, a ballet of electrons and holes dancing across junctions, making these transistors not just switches, but also amplifiers. And finally, we highlighted the importance of BJTs. Their role in the world of electronics is pivotal, from your home's thermostat to the most advanced supercomputers. They are the unsung heroes, the building blocks that power our modern world. So the next time you pick up your favorite electronic device, remember the mighty bipolar junction transistor. that makes it all possible.